Well, hello there, Mr. Bucko here with problems number 5, 6, and 7 from your Algebra Chapter 5 self-test, where we are solving proportions. I have number 5 on the screen, and we have to solve the proportion, and a proportion is two fractions that are equivalent, and we have a missing value here, so we have to solve the proportion, meaning fill in the value for this letter, for this variable, that makes this proportion, these two fractions that are equivalent, true. So we got to find out what does h have to be so that this fraction, h over 17, is equal to 6 over 101. There are many ways that we can solve proportions. However, the most efficient way in most cases is by using what is called, the book calls it the means extremes property, or other people call it cross multiplication. This is a very quick way to solve a proportion, and cross multiplying is pretty much exactly what it sounds like. We're going to multiply across, so maybe I guess it doesn't sound as nicely as it actually works, but we're going to take 17 and we're going to multiply it by 6. And then we're going to take h and multiply it by 101. So the denominator multiplied by the numerator of the other proportion, and the denominator of that other fraction times the numerator of the other fraction. And we get something like this. So what's happening here now is I've just used cross multiplication. I've done 17 times 6 and 101 times h. And cross multiplying, or the means extremes property, says that if you do that, those two products are equal to each other. So 17 times 6 is equal to 101 times h. This will work for any fractions that are equal. For any proportion that is true, this property will work. 17 times 6 is equal to 101 times h. Now we just have to solve the equation. We have a very basic algebraic equation now to solve. I see 6 times 17. I can do that. I know what 6 times 17 is. It's 102. So 102 equals 101 times h. Well, I have to find out what h is. So 101 times what gives us 102? Well, to solve that algebraically, I'm going to divide both sides of the equation by 101. So h is going to be 102 divided by 101. That turns out to be a decimal that may or may not end. Doesn't really matter. Doesn't look very nice in the calculator. So I'm going to leave it as a fraction. It's perfectly okay to leave this as a fraction. So h is going to be 102 divided by or over 101. That is the value that goes in for this value of h to make this proportion true. Not a nice number, but it makes it true. And we found that by using cross multiplication or the means extremes property, whichever you like to call it. Number 6, we have another proportion where we have 9/5 is equal to 4 times u over 3, and we have to find out what is the value of u that makes these fractions equal, or this proportion true. I'm not sure by looking at this. Again, there are many ways we can solve proportions. The most efficient way is cross multiplying means extremes property. So applying that property we just used in number 5, if I do 5 times 4u and then 3 times 9, those two products should be equal to each other, because that's what the means extremes property says. That's what cross multiplying says. This will be true always if the two fractions in the proportion are equal. Well, what I see a couple things I can do here now. I can do 9 times 3. 9 times 3 is 27. 5 times 4u is 20u. So now I have 20 times what gives us 27. Well, I'm not sure, but by using algebra, I can divide both sides by 20 and get 27 divided by 20, or 27 over 20, is equal to u. Once again, that's a fraction. I can't reduce it. Doesn't reduce at all. And 27 over 20 is going to be some decimal number that may or may not end. I'm not even sure. But I'm going to leave it as a fraction. Fraction is an exact answer, so I'm going to leave it as a fraction, and u is going to be 27 over 20. So what that means again is if I take 27 over 20 and I plug it into u right here, 4 times 27 over 20 divided by 3, that will be equal to 9/5. That's not obvious either, but it is true. And we found that by using the means extremes property or cross multiplication to find this value. Again, I never would have guessed 27 over 20 for u. Never would have been able to do it. Maybe would have been able to do it. Would have taken me a while. By using the means extremes property to cross multiplication, I found a very efficient way, or I have a very efficient way to find that value. And number 7, another proportion. We have two fractions that are equal to each other, and we have to find the missing value. We're going to use this. This one looks like a mess compared to the other ones, because now we have x's, an x in one fraction and an x in the other fraction, but we're going to find out here that our means extremes property, cross multiplication, it will work. So I'm going to take 24, and I'm going to multiply that by x, and then I'm going to take 8 and multiply that by 2x minus 3. And when we do this, when we set this up, we want to be very careful, because we have 24 times x from the 24 times x, and then we have 8 times 2x minus 3. You want to make sure you put the 2x minus 3 in parentheses, because you're multiplying 8 by the 2x and the negative 3. That's why there are parentheses here, because 8 is being multiplied not just by 2x, it's being multiplied by 2x and the negative 3. Once again, we have a very basic algebraic equation to solve. I can use the distributive property here, 8 times 2x and 8 times negative 3. That simplifies to be 16x. 16x is from 8 times 2x, minus 24 from positive 8 times that negative 3 is a negative 24. Now I have to solve for x, so I want to get all my x's onto one side of the equation. So I'm going to take this 16x right here, which is a positive 16x, and I'm going to subtract it to make it go away. And I get 8x. 8x comes from 24x minus the 16x from the other side equals negative 24. And if 8x equals negative 24, divide both sides by 8, and you get x equals negative 3. So the value for x in this proportion is negative 3.